In this video, we're going to find the different measures of spread for a sample data set. The first one is going to be the range for these grades, and the range is the fastest one to find because it is just the difference between the maximum and the minimum in a data set. The highest grade in this class is 100, and the lowest grade is 20, so our difference is 80, and there's our range. Next, we want to find the standard deviation and variance. So it's important that you're using the right notation. Because this is a sample data set, we use the letter S for standard deviation. And the formula is the square root of x minus the mean, which we call x bar for a sample data set squared. Then we add all that together and divide by the number of values minus 1. We know to use this formula, you want to organize it in a tabular format because that's going to make it a lot easier to understand. If we want to find the spread, the first step is to say how far is each of these values away from the mean. In order to find the mean for this data set, I'm going to quickly add together all of the grades on my calculator, 100 plus 20 plus 50 plus 90, and that gives me 260. I'll put that total in my table down here, below this darker line that represents my total, and then divide that by the 4 grades. And that tells me that x bar, the mean, is 65. So I'm going to take each of these grades and subtract 65. 100 minus 65 will give me 35. Next, I've got 20 minus 65, which is negative 45. 50 minus 65, which is negative 15. And 90 minus 65, which is 25. These are what are known as our deviations. That's why it's called the standard deviation for how far each value is from the mean. When you add them together, they should always add up to 0. If they don't add up to 0, it means you made a mistake somewhere. So we are good because we got a 0. The next step is you're going to square all those values. And these are ones that you'll probably want to type in your calculator because they'll be pretty large. 35 squared is 1,225. Negative 45 squared will be 2,025. Negative 15 squared is 225. And then I've got 25 squared, which is 625. If I add these 4 values squared together, that's this part of the formula. You add the deviation squared, you get 4,100. And now I'm ready to plug into my formula. The table helped me simplify the process, so now I have the sum of the deviations squared. Remember, we square them so that they don't perfectly cancel out and give 0. Squaring makes sure you only have positive numbers, so we don't get that canceling out effect anymore. And then we divide by the number of values minus 1. This is a change for the sample data set that you have to subtract 1. So that's going to be 4,100 over 3. If I take the 4,100, divide by 3, then do the square root, that is my final answer for the standard deviation, about 36.97 to 2 decimal places. If you wanted the variance instead, it's almost the same, except it's not square rooted. So the variance would just be the 4,100 divided by 3. If I go back on my calculator just to see what that value was again, it's 1,366.67. The purpose of this example is to show you guys how we can compare this set of grades to this set of grades and see which one has a bigger standard deviation and variance. So I'm going to do the process all again for extra practice for my grades for the second class. First, let's find the range. The highest grade in this class is 70 and the lowest one is 60, so the range is only 10. Again, this is a sample data set, so I'm going to use the same formula. We add together the deviations squared. The deviations tell us how far they are from the mean, and we square them so that they don't perfectly cancel out. Divide by the number in the sample minus 1, then take the square root so that we're back to our original units instead of units squared. In order to use this formula, I know we need the mean, so the first thing I'm going to do is add together all the grades, 60 plus 70 plus 62 plus 68. That gives me 260. And if I divide it by the 4 grades, again, the average is 65. So there's no difference in the average between class 1 and class 2, but obviously there's a difference in how far the values are apart, and we'll see that as we finish our calculations. So as I do the difference between each one here, I'll get my deviations, and they perfectly add to 0, which shows that I didn't make a mistake with my mean. The mean is the perfect balancing point. The reason we can't use the deviations just as they are is because they cancel out, so we square them in the next step. 5 squared will be 25, and 3 squared is 9. So when I add together 25, 25 plus 9 plus 9, I'll get 68. And now I'm ready to use my formula. The table helped me simplify to get this top part of the fraction, deviation squared summed, and I divide by the number of points minus 1. So I need to find out what 68 divided by 3 on my calculator is. 68 divided by 3 is about 23 almost. Take the square root and I get 4.76. If you did want the variance instead, remember it's the same thing almost, just not square rooted. So it would just be the 68 divided by 3, which is 22.67 to 2 decimal places. There we go. So as you can see, for our grades that had a much bigger spread, where we had somebody that was perfect and somebody that was failing, the standard deviation, range, and variance are all much, much larger than for the class where everyone was between 60 and 70%. For example, this standard deviation means that there's really only a spread of about 4.76 percentage points on average. That's the way that you can interpret the standard deviation, kind of like your average spread in the data set or average distance to the mean. It's about almost 5 percentage points. Whereas for the first class, that average distance from each grade to the mean is about 37 points. That's a very, very big difference. So when we're actually trying to summarize our data set, we always want to report both the measure of center, where the typical values or middle values are, as well as a measure of spread, which tells you how far away you are from the typical values. That's going to give you a lot more information than just the mean, which is actually the same for both these data sets. So that's why we need measures of spread as well.